In the previous video, we defined a function that can calculate and print the area of a sector for any central angle and radius. We compressed the code into a much simpler form and said goodbye to copy and paste coding. However, this function still has a problem. In the original program, sector area 1, sector area 2, and sector area 3 were assigned the areas of the first, second, and third sectors. Whenever we needed these results later, we could reuse them directly. But in our new version of the program, we don't have any variables storing these calculated results, so we can't use them afterward. You might be wondering, isn't sector area already assigned the calculated result? To understand this, we need to talk about scope. Variables defined inside a function are local variables and cannot be accessed outside the function. For example, if we define a variable a with a value of 3 inside a function, we can access it normally within that function. But outside the function, whether before or after calling it, Python will say that a does not exist, because it only exists within the function's local scope. Therefore, running code by calling a function is not exactly the same as running that code directly. From this perspective, although functions help us avoid repetitive code, not being able to access internal variables might seem limiting. That's where the return statement comes in. A return statement specifies what value a function should give back after it finishes executing. This return value can be assigned to a variable, printed, or used in any other way. Most importantly, it allows us to keep using the value outside the function. If a function doesn't have a return statement, Python returns none by default. That's why functions like print and append are usually called directly, while functions like len and sum are often assigned to variables. Our current sector area function only prints the result, it doesn't return it. Using the bun-making machine analogy again, it's like the machine makes a bun and only tells you what it made, but never hands it back. Once we add a return statement, we can store the result in a variable and use it for further operations. Now it's time to put this into practice. We previously wrote a BMI calculation formula. Body mass index equals weight divided by height squared. This time, our goal is to rewrite this calculator as a function. It needs to meet the following requirements. First, it should be able to calculate the BMI for any given weight and height. Second, during the function's execution, it should print a line your BMI category is, followed by the category name, such as underweight, normal, overweight, and so on. Third, it must return the calculated BMI value. You can pause the video now and try to write it yourself based on this information. Okay, I'll start. To define a function, valphi, followed by the function name, parentheses, and a colon. Since this function calculates BMI for any weight and height, both weight and height need to be included as parameters. The BMI formula is very simple and straightforward. Weight divided by height squared. Next, we need to determine the BMI category. If BMI is less than or equal to 18.5, the category is underweight. If it is greater than 18.5, but less than or equal to 25, we can simply write this condition as Geti BMI equals 25. This works because the case for less than or equal to 18.5 is already covered in the first branch. So, when we reach the second branch, BMI is already guaranteed to be greater than 18.5. Following the same logic for the next one, if BMI equals 30, the category is overweight. Finally, if it is greater than 30, that is obese. We can use Huiji elsewhere for this and set TOA category equals obese. Then we need to print it. The printed line is your BMI category is. We can use an F string here, placing the variable inside curly braces. Most importantly, we also need to return the calculation result. We turn BMI now the function is ready. Let's test it by calling the function, for example, with 1.8 and 70. We can see it prints the BMI category. If we want to see the actual BMI calculation result, We can assign the function's return value to a variable and then print it. We can see the calculated result is also successfully printed. See you in the next video.